In this lesson, we're going to explore the basics of electricity. We'll find out what it is, how it works, and how we can put electricity to work for us. Electricity is the movement of electrons. It's an invisible force that can be easily converted into light, heat, sound, or motion. In this section, we'll explore what electricity is and how it works on the atomic level. To understand electricity, it helps to understand elements and the atoms that they're made of. An element is the simplest form of matter. It's the purest form of a substance, one that isn't combined together with other substances. Atoms are the building blocks of matter. They're the smallest piece of an element that still contains the properties of that element. Every atom is made up of the same parts. The nucleus is the part in the center, consisting of protons and neutrons. Protons are positively charged atomic particles, and neutrons are uncharged or neutral atomic particles. These are the particles that give an atom its mass. The atomic number of an element is equal to the number of protons in the nucleus. This is how we distinguish one element from another. If two atoms have different numbers of protons, they are different elements. Each element has its own atomic number. This image shows an atom with two protons, so this is a model of a helium atom. Electrons are negatively charged atomic particles. These are the tiny particles that orbit around the outside of an atom along paths called orbitals. Electron orbitals tend to form layers or shells around the nucleus of an atom, and the outsidemost layer is known as the valence shell, and it contains the valence electrons. These are the electrons that we are interested in as we study electricity. As electrons form layers around an atom, different layers can hold different numbers of electrons. The first layer can only hold 2. The second layer holds 8. The third holds 18, then 32, 50, and the sixth layer can hold 72. The orbits closest to the nucleus fill up first, and then electrons try to fill each layer moving outward. The valence shell, or outer layer, never has more than 8 electrons. In general, atoms like to have their valence rings either filled, containing 8 electrons, or empty, containing 0. Take a look at this model of a copper atom. The electron orbitals have been laid flat so we can see how many electrons are in each layer. How many electrons are in the valence orbit? Copper has 29 protons and 29 electrons, so if the electrons fill the orbitals from the center outward, there will be 2 in the first layer, 8 in the second, 18 in the third, and 1 lonely electron left over in the valence shell. Copper is a conductor, which means it allows electricity to flow through it easily. Why do conductors behave this way? It all has to do with that valence electron shell. If an atom has only a few electrons in its outer orbit, it has a weak hold on those electrons and will allow them to flow from one atom to the next easily. Now let's take a look at this model of a fluorine atom. Fluorine has 9 electrons total, so there are 2 in the first orbital and 7 in the valence orbital. Because the valence orbit is nearly full, fluorine atoms hold on tightly to these electrons and do not let them flow from one atom to the next. Materials that behave this way are called insulators. The difference between conductors and insulators has everything to do with how many electrons are in the valence orbit of the atoms. An electron from one orbit can knock out an electron from another orbit. When an atom loses an electron, it becomes charged, meaning that its positively and negatively charged particles are out of balance. When this happens, the atom seeks another electron to fill the vacancy. This transfer of electrons can cause a chain reaction in which electrons flow from atom to atom, knocking electrons loose and taking their place, one by one. This flow of electrons from one atom to the next is electricity, occurring at the atomic level. The difference between conductors and insulators is a big one when it comes to electronics. Conductors are materials with 1 to 3 valence electrons. They give up the stragglers easily, which means electricity can flow easily between atoms. Examples of conductors that are commonly used in electronics are copper, gold, and silver, although the list is long. It's common for different metal elements to be mixed together into alloys to achieve exact conductive properties. Insulators are materials with 5 to 8 electrons in the valence shell. They tend to hold on to those electrons and try to combine with other elements to fill out the valence layer. These materials don't let electricity flow through them easily, so insulating materials such as rubber, plastic, glass, and ceramics are often used in electronics to prevent electricity from flowing in certain ways. Now that we understand what electricity is and how it flows through different materials, in the next section we'll take a look at electrical circuits and the 3 variables that govern how they work: voltage, current, and resistance.